go again. So I'm Madhav Chitturi from University of Wisconsin-Madison. Talk about neural correlates, older driver performance. Before I begin, I would like to acknowledge our other team members, beginning with David Noyes, who served as the PI of this project, as well as Kelvin Santiago, Andrea Bell, and Hiba Nasaruddin. We are all in the civil engineering department here. As you can guess from this title, it's an interdisciplinary project. We also have the School of Medicine and Public Health involved. Their names are on the left. Dorothy Edwards, she's a faculty in kinesiology and is also a member of the Institute on Aging. We also have Veena Nair and Vivek Prabhakaran. They are from the neurology or neuroradiology department. So we did a broad and in-depth review of the literature on various topics. We looked at safety of older drivers, what kind of crash types they are involved in, what kind of maneuvers. We also looked at age-related declines and how they impact driving, be it visual, cognitive, or their physical abilities. And we also looked at simulator studies as well as on-road studies and neuropsych assessments, which include perceptual, cognitive, and psychomotor tests. So the idea was, what does the literature say about how would, what are the crash types older drivers are involved in, and how would one identify a potentially at-risk older driver? Finally, I'll also talk about the assessment we did of using fMRI, which stands for functional magnetic resonance imaging, which is kind of a neuro imaging technique. So essentially it's an MRI, but they measure the brain, blood flow in the brain. And how could we use fMRI and driving simulation to kind of work together to come up with a better screening tool, so to speak. I'll talk more about it as we go through the presentation. With rapid advances in modern medicine and technology, the human lifespan has increased dramatically, especially in the developed world. And we have people driving into late 80s and even 90s. Owning and driving a car represents autonomy and independence, which is kind of very vital actually. So as you can imagine, more than half of older drivers use their own cars for daily activities. So, but this has created a pretty challenging situation because you have never seen this happen before. You have older and older people driving on road, and we know they have driving difficulties. So some of them are listed here. Now, how do you balance these two? So how do you keep the older population mobile as well as safe? So that's a challenge. So literature is also very clear that older driver crashes are primarily from age-related declines. So it's not due to risk-taking or careless driving or other forms of driving which are leading to crashes involving older drivers. It's basically age-related declines, and all these listed here, be it sensory, perceptual, cognitive, physical, or general driving knowledge deficiencies. So these are all consequences of normal aging. So there's plenty of research on, of course, how these declines can be further accentuated by neurological diseases like Alzheimer's dementia, Parkinson's, or schizophrenia, but even normal aging results in these declines in these categories. In sensory, as you can see, most of them are related to vision because, as you can guess, vision is one of the primary senses through which we gather information for driving. And also about perception, cognition, and physical ability to basically, for example, rotate their head, or neck mobility, or moving their legs to move it from the gas pedal to the brake pedal. So all these affect driving safety. So we also looked at what kind of maneuvers may lead to higher crash involvement. And some of them are listed here. Left turn against oncoming traffic, like for example at a signalized intersection, drivers are making a left turn at a permissive pace. or crossing non-limited access highways like on expressways. You have a minor road two-way stop. They need to make a through movement or a left or a right turn movement. Lane changes on freeways, complex interchanges, and another very challenging situation for older drivers is non-traditional designs. So this could include roundabouts, restricted crossing U-turns, diverging diamond interchanges, single point urban interchanges, all the new designs which are very challenging for older drivers. And again, as I said, so these patterns are very different from the crash types that younger drivers are involved in. So their patterns are more related to risk taking like speeding, maintaining shorter headways, involving alcohol. And in terms of difference between male older drivers and female older drivers, we also see that, although in general female older drivers are safer, in terms of left turn crashes and gap acceptance related crashes, older male drivers are safer. So, kind of summarize what's the problem we are dealing with. So we have an increasing older population, and I'm going to speak more about how it's going to get more. The older population is going to increase, and the driving cessation has adverse consequences. So there's a lot of research which shows how driving cessation can lead to increased dependency, social isolation, depression, increased risk for nursing home placement, and even death, actually. On the other hand, older drivers' crash rate is second only to adolescents. So we need to balance these two, the driving privilege and their safety, ability and safety. And it's a very difficult task. So several efforts have tried to identify markers which can characterize at-risk older drivers. So, a priori, how could you identify somebody is an at-risk older driver? That's the question. A lot of research has tried to address. So they have taken various approaches, which include neuropsych assessments, physical assessments, performance metric in the driving simulator, and of course on-road assessment. But the challenging thing is the evaluations of these tests or markers have found that off-road assessment test batteries, they do not predict significant crash involvement, or they are too inaccurate to be used on a simple pass-fail basis, which is what you would want in DMV kind of a setting. So the question is, could Neuro Imaging enable better assessment? So that's the question, or at least that's the question we are trying to move to. So in terms of Neuro Imaging, so there's a lot of research which has shown Neuro Imaging assessments, they are probably even better than neuropsychological assessments in predicting behavior in individuals. So basically, the premise is the changes in brain function and structure are intimately related to the changes in cognitive functions, which kind of follows on, it kind of affects other tasks, how they can perform other tasks. So, doing it backwards, if we could identify those changes in the brain, then we'll also see their cognitive impairments and consequent decline in performance in doing other tasks. So recent studies have shown that using fMRI, functional magnetic resonance imaging, you could predict human behavior such as likely success in quitting smoking and learning and so many other things. So that's what kind of intrigue does to propose this project. Could we use neuroimaging to come up with better tools or better assessment tools to assess at-risk older drivers? In terms of objectives, so we had 4: doing a broad, in-depth literature review to identify, to gather available information related to older drivers, and understand the state of the art and research regarding using these neuropsychological tests. I'll talk about some of these later on. We also wanted to evaluate the feasibility of using fMRI and driving simulator to develop better assessments. And finally, what type of experiments need to be conducted to actually accomplish that. So just to be clear, we are not suggesting that you should put an MRI scanner at every DMV and scan every older driver before you decide to, the DMV decides to give them a renew their license. That's not what we are suggesting. What we are saying is, could we use neuro imaging to get to the biological basis of safe or unsafe driving, to characterize safe or unsafe driving? And can we use that knowledge to develop better screening tools? So that's the question. So in terms of literature review, we'll talk about all these things: general information, their impairments, driving sim studies, neuropsych tests, imaging studies. So I'll try to go through these quickly because probably most people are familiar with this. So general information about older drivers. As we have talked, they're the fastest increasing demographic, actually not just in the United States, in the developed world in general. By 2030, 1 in 5 people will be over 65 years. Again, by 2050, close to 90 million people, and very shortly we are going to have close to 40 million licensed older drivers. So if you can actually think about it, in 1970, older drivers being 65 years and over, they were only 8% of the driving population. That number was close to 14% in 2000, and now we are approaching 20% and more. We have an ever increasing or increasing older driver population. In terms of safety, so research shows that fatal crash involvement of older drivers will more than double in the next decade. So again, obviously somebody will say these numbers are questionable. I agree, especially with the impending autonomous vehicles. Yes, all these numbers are subject to revision, but in terms of literature, this is what is out there. And if you look at the graph, so accident rate per vehicle miles traveled for different age groups, again, this is very familiar. It's very high for the young licensed drivers and kind of drops down and stays steady till about 65. And once you cross the 65 and over, it again goes back up. Especially with 75 and over, you can see a further increase in the crash rate. Looking at this crash involvement from a different perspective. So the previous one looked at crash rate in terms of vehicle miles traveled. So these graphs, or these two graphs, are showing driver involvement rate. So this is from the 2014 data from NHTSA. It looks at driver involvement rate for 100,000 licensed drivers by age and sex. Again, as you can see, you have, I mean, in general, men have higher crash involvement, especially almost twice or more in terms of fatal crashes across age groups. It's about twice for the older group. Again, for the injuries, as you can see, the crash rates are higher for men than for women. In terms of the fatalities versus injuries, as you can notice, there's a difference because clearly data shows the VMT, or vehicle miles traveled, is smaller for older drivers than for other populations. In addition, their fatal crash involvement is also actually, although in terms of involvement it's a smaller number, but outcome is higher because of their frailty, because they're so fragile. In the same crash, probably a driver from a different age group would not have gotten killed, but an older driver gets killed because they are more fragile. Coming back, looking into what are the maneuvers associated with crash involvement for older drivers: turning, merging, changing lanes, gap selection, as you can see, that's a big one. And also any complex situations with information overload. So this kind of captures complex interchanges and any of these novel designs that are being used on our roadways. So they tend to really exert the older drivers. Again, as we said, their crash types are very different when compared to the younger drivers. So they do not involve fatigue, alcohol, weather, speeding, and all those other risk taking. So basically, it's a different kind of crash etymology compared to the other age groups. Now coming to functional impairments. I mean, everybody experiences with age several physical and functional declines. Again, this differs from person to person, and depending on this healthy aging versus older drivers with some neurological disease. So vision is the most important sense, and many of these are related to vision, as you can see. So visual acuity, contrast sensitivity, color vision, night vision, and sensitivity to glare from headlights, and reduction in the visual field of view. So these are all things which affect older driver performance. In terms of the factors that affect older drivers' involvement in vehicle collisions, as you can expect, there is age, obviously, there is gender. We saw the clear difference between male and female. Eyesight, cognitive deficiency could be related just to normal aging or dementia related. Again, declines in physical capabilities and other functional impairments. So we'll talk a little bit more about these functional impairments because it's kind of critical to understand what are the functional impairments. So we can actually develop tests, be it neuropsych, neuro imaging, or a combination of both, or driving simulator, which can capture or identify those functional impairments because that's the key. So these functional impairments are the underlying problem, which manifest in older driver safety issues. So there's a lot of research which looked at various aspects related to vision. First thing, easiest thing is visual acuity. Is it 20/20 vision? No. So yeah. So does that affect driving? Yes, it definitely affects driving, but a lot of research has concluded pretty much conclusively that there is little support for a significant relationship between acuity and unsafe driving. So yes, acuity affects driving, no question, but there are very many other things related to vision which affect driving safety, and these are not captured by just measuring visual acuity. The second one is visual field impairment or peripheral vision. This is also done in many DMVs. While it definitely affects driving, such as ability to identify road signs or avoid obstacles and reaction time, but it does not affect safety to a very great degree. And there's also research which looked at contrast sensitivity. So again, for the general older population, it's not a big issue, but those with cataracts, yes, there is some correlation between contrast sensitivity and their driving performance. Moving on, they looked at color vision deficiencies. Again, no major correlation between the two. So, I mean, there are many other things which have been looked at. So, just to summarize, so what literature kind of points is, so visual sensory impairments and eye diseases, they alone cannot be used to identify at-risk older drivers. So, you need to look at something else. We need to look at visual attention and visual processing speed. So these turn out to be better markers or better characterizations for at-risk older drivers. So there's a lot of research on this topic beginning in 1970s actually, where they found a significant correlation between visual attention or visual processing and crash involvement. So this test was developed, it's called useful field of view. So basically it is measuring the visual field area over which a driver can rapidly extract information without moving their head or eyes. So there's been a lot of research which shows poor performance on this UFOV significantly correlates with crash involvement. We'll talk more about it later. So unsafe driving, in terms of, again, to kind of try to get it all together, we talked about vision in depth. So it correlates with visual search and sequencing, trying to manage attention between different tasks, as well as spatial memory and perception of three-dimensional structure. So as one would expect, cognitive impairments are a big risk factor for unsafe driving, and this has been shown time and again when drivers have dementia or other neurological diseases, which result in significant decrease in cognitive functions. it also significantly affects their driving behavior and safety. So some research has shown it's more than twice. So for drivers who have dementia, it's more than twice than for regular older drivers. In terms of physical ability, obviously the range of motion, head, neck, arms, legs, along with flexibility, balance, and all these things play a very important role in driving. And what research has shown, especially when they lose some of their physical motion, they kind of self-regulate. So they reduce or even avoid driving due to that. So research also looked at coming up with kind of remedial measures. So let's say somebody does have impaired visual attention or cognitive function. Could we do something to improve their driving? So there's been a lot of research which looked at cognitive training and even visual attention training, and how that shows up, reflects back in their driving performance. So some research shows that once drivers receive training for speed of processing and reasoning, that lasts for almost a 6-year period after the training. It reduced their at-fault crashes for older drivers for up to 6 years. So there is some good research on that topic. So it basically uses this concept of modulating the plasticity in brain areas. So how can you facilitate development of the adaptive networks, which are good ones, and suppress the maladaptive networks, which are the bad ones. So essentially that's the concept which is used in this cognitive training. In terms of simulator studies, there have been a lot of simulator studies, and I won't spend too much time. Everybody knows about driving simulators and how they are good. They're economical. You can do a lot of things, provide accurate observations on a whole host of parameters. So naturally, a lot of studies have looked at it. How could we use driving simulators to assess older driver performance, and how does it correlate to their driving record? So they've used driving speed, use of indicator, lane position, stopping distance, and so many other parameters which can be readily obtained. And so, in summary, majority of the studies found a moderate to high correlation between simulator and on-road driving, while a few of them showed low correlation. But in general, you could say that there's a high correlation between simulator performance and on-road driving. And in terms of quantifying that, simulated driving index was shown to explain about 2/3 or close to 67% of the road assessment index. So when you compare road assessment to simulator, the simulator can capture close to 2/3 of that. The simulators have also been used to improve drivers' performance skills, and their driver interaction with the environment, driver training, and how do drivers interact with other in-vehicle technologies, both upcoming, incoming technologies. In simulator sickness, everybody knows this is because of the incompatible signals between the visual, auditory, and the motion systems, and more of a problem for older drivers. That's why we included it here, especially when you have participants age 70 and more. They have a higher likelihood of experiencing these symptoms. But the interesting thing is there is no association between dropping out and cognitive differences. So the simulator sickness is not due to cognitive differences. So that's important from this particular project's perspective, because we are trying to address that. Now coming to the neuropsychological tests. As we said, older drivers encounter a decline in cognitive abilities, and requiring frequent on-road exams. Yeah, somebody could suggest that's one way to do it. One thing is it's not very economical, and also research has shown that requiring these frequent on-road exams is in itself a deterrent for older drivers, and many of them choose not to renew their licenses for that reason also. So we don't want to go that route. So this neuropsychological assessment, what it does is basically tries to evaluate cognitive functioning, and it's more like a first principles approach, because we are trying to see or assess their cognitive abilities and how they might impact driving. So there are a whole bunch of neuropsych tests. I won't talk about all of these, but I'll highlight a few of them. So the different domains and the cognitive abilities and the different cognitive tests that are used, these are all part of standard tests that are used. But some of them have been shown to be very, very important from a driving perspective. I already talked about this useful field of view. So basically what it is it measures the ability to perform a visual identification task. So it has three parts. The first one is a visual identification task, and also the ability to divide attention between a central and peripheral stimuli. So when you have multiple stimuli in the central vision as well as in the peripheral vision. And finally, a more challenging one, to select peripheral stimuli from among distractors. You have multiple peripheral stimuli and you need to pick one. So the size of the UFOV, useful field of view, is what is measured in this test. And it has been shown if there is more than 40% decline, it significantly affects driving performance. And the next one is the trail making test. Essentially what it is they are required to connect a set of dots as quickly as possible, but still maintain accuracy. So again, there are two parts to it. In the first one, they're all numbers like 1, 2, 3. So you need to join 1, 2, 3. They are randomly spaced. And you need to connect them in the sequential order. In the second part, the subject has to do it between numbers and letters. So 1A, 2B, 3C, like that, 4D. So how much time it takes for them to do it and how many errors they make. So that's the trail making test. And then there's the end-back test, end-back task or the word recall or picture recall, which basically says, you're shown a series of images or words and you have to say if it matches a word or an image that was shown immediately before this or 2 steps before that. So that's the end-back. So it's 1 back, 2 back, 3 back. It's very, very challenging as you would imagine. It measures basically the encoding and attention as well as memory and decision making. So it's very, very challenging task. Finally, you see the Stroop color word. This is a very interesting one. So it's basically what it is trying to see is, can the driver or a subject inhibit cognitive interference when there are multiple stimuli? So the way it does is, all of us, we can read words much faster than we can identify and name colors. That's how it is. So for example, if we write the word green in red color and the word mouse in red color, and if you were to read the colors of these two words, not what is written, not the word, but the color of the word, it would take us much longer to say a red color for green written in red color than mouse written in red color. So basically this would get much worse with age. So that's what this is testing. Now getting back, so most commonly studied are the size of the UFOV, as I said, the trail making test, and this digital symbol substitution. So this one is a digit symbol pairs are shown, and then following that there's a list of digits and the subjects will have to write the corresponding symbols corresponding to those digits. So the number of correct symbols and the time they took, that's the measure. So this is another one which was found to be significantly correlated with driving or driving related functions. And back task, I talked about it. Stroop color and word test, I talked about it. In terms of neuropsych test, so there's research which shows that there is definite correlation between performance on these neuropsych tests or several of these neuropsych tests and on-road performance and crash involvement, driving record. As I said, poor scores on the UFOV also showed increased crash involvement. So research is pretty conclusive on that one. So some research, what they did was they also looked at relationship between neuropsych tests and the driving simulators. So again, They looked at these different measures from the driving simulators and how they correlate with neuropsych performance. I'm not going to talk in detail about all this, considering the time. So to kind of summarize neuropsych tests, speed of processing, memory, and visuo-spatial abilities, these are significant predictors of older drivers' safe or unsafe driving. And again, in terms of simulator variables that are related to these, we have these average speed, reaction time, lane position, headway, and errors that they make. So all these have been shown to kind of correlate with older driver performance. Now, changing gears, we talk about neuropsych tests, we talked about driving simulator studies. Now we are going to talk about neuro imaging studies. So again, neuro imaging is a broad term. We specifically looked at, as I said, functional magnetic resonance imaging, which measures the blood flow to the different parts of the brain. The idea is when a region of the brain is used, there is more blood flow to that particular region. So that's the principle behind fMRI. So you measure the blood flow, and that greater blood flow means greater activity in that particular part of the brain. And you're trying to quantify this brain activity and corresponding to the different tasks that people are doing at the same time. So as I said, some few studies, not a whole lot, they have looked at driving simulator and functional MRI to study brain activity during driving. So what kind of brain activity is stimulated during driving? So some of this was also looked at in the context of uh, distraction. So kind of mapping the different brain regions and driving performance. So fMRI is kind of better than other techniques because, as this one, it is non-invasive. There are other non-invasive techniques too, but it also captures, get a much higher resolution, so to speak. So it's spatially distributed and it's temporally dynamic. So you get a much higher resolution picture of what's actually going on in the brain when subjects are involved in different tasks. So I illustrate that here in this one. Again, this is not exactly driving. So these studies looked at older versus younger subjects while performing a memory task. So as you can see in the older adults, they use more parts of the brain to do the same task than in the younger adults. Same image, same kind of thing is illustrated in the image panel below. So by his high bihemispheric activation, so both sides of the brain are being activated in the older adults relative to the younger adults when doing is processing speed. So basically, they're trying to compensate by bringing in more regions in their brain to accomplish these tasks. So in terms of neuroimaging studies, there have been a lot of them, but many have been kind of, I would say, rather simple or simplistic. So they don't really involve the full steering wheel, brake pedal, gas pedal, and all other things that go in actual driving. So they present simple visual stimuli, a foot pedal or a button response, or using joysticks. So as I said, they are not realistic enough, so to speak. But again, not to discount all these studies, they show valuable information about how different parts of the brain are involved during driving and during rest periods. So again, not going into all the details of which part of the brain is involved in which action or which category of action, prepared actions, unprepared actions, planning and monitoring, which are more like the strategic and the tactical level hierarchy of tasks. So I'll quickly go through these next few slides, which show how different parts of the brain are, so to speak, lit up or activated for these different kinds of tasks. So this is for prepared actions, different parts of the brain, how they are activated. This is for unprepared actions, swerving or reacting to, trying to avoid a potential collision and things like that. And this is about planning and monitoring, planning your trip, or planning your route or planning the lane change and things like that. So kind of summary, this is a picture of the brain, different parts of the brain, and the different functions of those different parts of the brain and how they relate to major driving functions. I'm not going to talk through each of these, but go on to the next ones, which talks about what we actually did beyond this literature review on this project. As I said, I mean, there are a whole bunch of neuropsych tests which have been shown to be correlating with driving performance and driving record, crash record. But the issue, as I said, was it was not practical to be used. So our premise was, could we use neuro imaging, specifically functional, fMRI, to come up with better screening tools? So that was the premise of this project. Actually. So we wanted to see if we could actually use fMRI while doing driving tasks like in a driving simulator. So that's what is shown in this picture here. So there's a screen which is showing you, the roadway or the scenario, and this image is shown in a mirror to the subject in the fMRI machine there, and that was the real challenging part. So there's a pretty small mirror, and it's kind of just a few inches away, and that's actually me in that photograph lying in the fMRI machine. And it's pretty claustrophobic because you really cannot move your head. If you wanted to do any realistic scenarios such as what we talked about, right? Making a left turn at a signalized intersection on a permissive left turn, or making a through movement on an expressway from a minor road, at a stop control minor road, or merging onto a freeway, or roundabouts, or any of these, it's very hard to put subjects in the MRI machine and have them drive through those scenarios. Because, as I said, so those are the common crash types, and those are the scenarios which are really problematic for older drivers. So what we found was, maybe I should take a one step back. So we developed, the other challenge was developing an MRI compatible steering wheel. So because you cannot have any ferrous metal in this room, so developing a MRI compatible steering wheel, that in itself was a big challenge in this research actually. So we managed to do that with help from some others, and we tried this, and that was the experience we had. Basically, you cannot put older or any subject for that matter to a realistic driving simulation scenario while they are in this MRI machine. So I kind of talked about this. So significant limitations in the field of view, difficulties in controlling through simple movements, because you cannot move the head or anything. So in terms of conclusions, what we kind of achieved at the end of this project is, we have identified what is the current state of the practice as state of the research, and as well as what are the gaps, or what is kind of lacking, or where improvements are required. And all the neuropsych tests are correlate well with on-road driving and simulator tests. They are really not good enough to be used as a screening tool in a DMV type setting. So, and these neuro imaging studies, they have been shown to be very, very, actually in some sense better than neuropsych tests in predicting actual subject performance in real world tasks. And we did do this kind of pilot, develop this MRI machine compatible driving wheel and everything, the setup to actually do a driving simulator in the MRI room. We did some pilot testing to see how that would work. As I said, it's kind of impractical to expect to do a driving simulator scenario in the MRI machine. So rather, what could be, so then what are other options? We could come up with small tasks which may not be which do not capture the entire scenario or the entire movement, the entire maneuver, but portions of it which could be mimicked rather easily even within the constraints of this MRI machine. So we feel that is the logical step to do, and of course, by the time we got to that, the project ended. So, but we are hoping in future research we could pursue this further. And that is the end of my presentation today. And if there are any questions, I'm happy to take.
Hi, Madhav. We have a question coming in right now.
Okay.
It might not have been a question. It might have just been. Oh, here we go. Can you give an example of how your neuro imaging results have helped develop or adjust a neuropsychological test so the predictive accuracy of crash risk of fitness to drive will increase?
So yeah, so actually we could not get to that point, as I said, because of what we found when we did this pilot run, that we were not actually able to do the driving simulator scenarios in fMRI. So we actually could not get to that point, and we are hoping to do, as I said, some of this future research. But yes, at this point, we have not done that particular aspect.
A follow-up question: what has been done using EEG during driving or simulation?
So there has been good amount of work using EEG, but the thing was, research has found that the resolution that you get from EEG is not sufficient to do something like this. So that's the motivation or reason for using fMRI, because EEG, you could put on the EEG cap, have the subjects in the driving simulator and do it that way, but it does not have the same resolution that the fMRI can provide. So that's the motivation for using fMRI versus. But yes, there has been some research on using EEG.